Okay, you guys, so today we're going to go ahead and keep studying about the properties of logarithms. For those of you following along in the textbook, we are working in section 7.4. Okay, so first up, let's just go ahead and take down some of these properties of logs. So, the properties of logarithms work very similarly to how the properties of exponents worked. So as you notice that if we have the log of base b times the product of m and n, it can be expressed as from a single log into two separate logs with the addition property. So instead of it being the log of base b times mn, it can become the log of base b of m plus the log of base b to the n. So notice we went from one single log into breaking it into a sum of two logs. And again, the whole purpose of us studying properties of logarithms is to be able to solve log equations. And so sometimes we're going to need to use these properties to make the equations we're solving simpler. Okay, so then let's go ahead and go on. So remember when we were dealing with the properties of exponents, if we had the same base and we divided exponents, that meant we ended up subtracting. Same thing works with logs, and again remembering logs and exponents are inverses of one another. So for log properties, if you have log base b of m divided by n, that is equivalent to the difference of log base b of m and log base b of n. So again, one single log into two separate logs. And then lastly, we have the power rule of logs. So now when we have a single log raised to the power of k, I've always kind of envisioned it as like k got to walk down the ladder. And so we can actually go ahead and say that that is equivalent to saying k, and this symbol here, you guys should have been a multiplication symbol. So this is now k becomes in front of the log, so the coefficient of it, multiplied by log base b of m. So these are going to be the properties of logs we use. So let's go ahead and see some example problems. So for the first problem here, we're going to express each single log in terms of the two logs of log base 2 of m and log base 2 of n. So here's our first problem. Again, remember, think of this entire thing right here as an input. So we're going to go ahead and right now notice that we have a product. So I'm going to go ahead and first use the addition property of logs. So I'm going to go ahead and make this become log base 2 of m squared plus log base 2 of n cubed. And so some of you might think, okay, we're done, but again, you want it to be exactly like log base 2 of m. So notice I still have this exponent of 2. So according to the third property that we wrote down from the previous slide, this 2 can go ahead now, and it can go ahead and come down into the front. Same thing with this 3 over here. And so we're going to go ahead and make that move now. And so we're going to end up with 2 times log base 2 of m plus 3 times log base 2 of n. And then according to the directions, that's exactly what we wanted to do. We wanted to take this single log and break it into the sum of two logs using base 2 of m and log base 2 of n. So this is indeed our final answer. Okay, so let's go ahead and try a second example here. And so second example now, if you want to go ahead and give it a try yourselves, remember you can pause the video and give it a shot, and then you can always fast forward to catch up to the answer after you've given it a try. So since now the entire product is being raised to the exponent of 5, I'm going to go ahead and bring the 5 down first. And so when I bring the 5 down first, we're going to go ahead and have this be 5 times log base 2 of mn. But again, remember the whole goal is to write it in terms of two logs of an input m and an input n. So now this log is going to be exploded into two logs using addition. So we're going to go ahead and leave the 5 in front here, but then we've got to go ahead and open up our distributive parentheses, and we're going to end up with log base 2 of m plus log base 2 of n. It is super important that I point out to you at this point that we can only use the properties of logs if the bases are the same. Okay, so these properties not only work from product to sum, but we can also go from sum back to product, but that is only the case if these two bases are the same. Just like with properties of exponents, you can only use the exponent rules if the bases are indeed the same. Okay, so let's go ahead and kick it up a notch, and we're going to do a third example here. So our third example, we've got log base 2 of the square root of m divided by n to the fourth. So mother lode problem. First step, let's go ahead and ditch the radical. We learned in the previous unit that we can express a radical or a square root as a quantity raised to the 1/2. So we're going to go ahead and do that first. So we're going to make this be log base 2 of m divided by n to the fourth raised to the 1/2 power. So that is exactly equivalent. Now I'm going to apply my properties of logs. So the first property I'm going to go ahead and apply is that power property. So this 1/2 is going to go ahead and come down in front. And so we're going to have 1/2 multiplied by the log base 2 of m divided by n to the fourth. And so now I've got to go ahead and deal with the quotient. And so when I have quotient, I'm now going to use the difference property. And so this is going to be 1/2 multiplied by log base 2 of m minus log base 2 of n to the fourth. We're almost done, not quite done yet though, because now we have this log right here raised to the fourth power. And remember, in the original directions, we wanted to just simply be log base 2 of m and a log base 2 of n. So just like we did in the first step, we're going to use that power rule again, and we're going to bring that down there. And so our final answer is going to be 1/2 times log base 2 of m minus 4 times log base 2 of n. And this is now in simplest form. So again, all of these examples we've done so far, we've gone from one single log and broken it into two logs, either by sum or difference. So now let's go ahead and see what happens when we go in the opposite direction. So the directions are going to change now, and we are going to express each one as a single log. So notice we have two logs here, and we now want to write it as one log. Again, always check to make sure that your bases are the same. If they do not have the same base, you cannot use the laws of logarithms. So since they do have a common base of 10, we're going to go ahead, and because of this addition right here, we're going to go ahead and combine them using multiplication. Ooh, but now I just noticed we actually have this 3 in front. So before we do that, we probably want to send this back up. So again, we're using the properties in reverse. So we're going to go ahead and take this 3 and bring it back up to its exponent. So we're going to get log base 10 of p plus log base 10 of q cubed. Now that I've got the coefficients taken care of in front of the log, I can go ahead and combine to make a single log. And so since it's addition, that's going to become multiplication for a single log. So it'll be log base 10 of p multiplied by q cubed. And that is now expressed as a single logarithm. Okay, we're going to go ahead and take care of one more example. And so we're going to go ahead and take care of, I'm going to skip number 5 and we're going to do number 6. And so for this one, notice we now have a constant over here that's not expressed in terms of a log. So we have to kind of remember from the previous lecture how we could write a number as a log. And so we're going to go ahead and take care of this step first. So this, I'm asking myself, how can I write that to be just 2? And so if I want it to be base 5, I'm going to go ahead and ask myself, okay, so log base 5 of what number would give me an output of 2? Well, Another way to think of it is 5 to what power equals 2, okay? Or 5 to what power, 5 to squared would equal what input, and that would be 25. And so this is equivalent to saying that. So we've now got log base 5 of x plus log base 5 of y plus log base 5 of 25. And now what we're going to go ahead and do, since all of these are addition, we're going to go ahead and combine it to be a single log, again, since they have a common base of 5. And so this is going to become log base 5 of x times y times 25. And to make things look a little bit how we're used to seeing, we're going to go ahead and put that 25 in front. So log base 5 of 25xy is going to be our final answer there. Okay, so that goes ahead and concludes the first video for properties of logarithms.